All right, here we go. Second time at this. All right, everybody go ahead and get out your homework. Let's check it. It's 10.1, 1 through 20 all. I'm going to call these out kind of quickly, right? So you can always pause the video and go back. Once we're done correcting, I need you to go to the Google Forms and write down how many you missed for homework. It'll be the first question. All right, here we go. Check your work. Number one, the area was 1,050 square centimeters and the perimeter was 130 centimeters. Number two, the area was 44 square meters, the perimeter was 32 meters. Number three, the area was 2,665 square kilometers and the perimeter was 212 kilometers. Number four, the area was 6.72 square units. Notice there were no units, so we just simply say square units. And the perimeter was 13.8 units. Number five, the area was 4,416 square millimeters, and the perimeter was 280 millimeters. Number six, the area was 1,760 square centimeters, and the perimeter was 174 centimeters. Number seven, the area was 2,490.67 square kilometers, and the perimeter was 205.6 kilometers. Number eight, the area was 6,838.845 square meters, and the perimeter was 478.9 meters. Number nine, the perimeter was 40, and the area was 93.75. They should probably put units on this, but in the book they didn't put units. No, you should put units. Okay, so they would all be units or square units. Number 10, the width was 5, and the perimeter was 34. Number 11, the length was 80 and the perimeter was 250. Number 12, the length was 6 and the area was 15. Number 13, the width was 0.4 and the area was 3.44. Number 14, the length and the width were both 1. Number 15, the area was 74 units squared. Number 16, the height is 3 units. Number 17, the base is 0.5 units. Number 18, the area is 45.76 units. 19, the height is 4. And 20, the base is 9. Hopefully you did well on that. Go ahead and pause the video. Go to the Google Forms. Question number 1 says, how many did you get wrong? Go ahead and answer that question and then come back to the video. Okay, here's our calendar. We're going to do a couple shapes today. We'll finish it up tomorrow. Tomorrow kind of more like a practice day. If everything stays as it should, after spring break we'll come back to a CMAS prep and then we'll take the CMAS test that following week. Here is your homework. Go ahead and copy that down. Remember, this will also be the last slide as well too. And it's a video, so you can always pause it wherever you need to. Rewind it, play as many times as you want. Okay, today we're going to be doing areas of triangles and trapezoids. Areas of triangles and trapezoids. Here we go. 2 objectives, calculate the area of a triangle and trapezoid. We've talked about triangles before in the previous chapters. Let's see, a triangle was a polygon with 3 sides. Hey, there's one right there. Remember, all polygons are made by segments joined at their endpoints. Poly meaning many, gon meaning angles, so something with many angles. This one has 3 angles. It also has 3 sides. All right, we're going to label the parts of a triangle. So I need you on a piece of paper, I need you to draw me a triangle. Any triangle will be fine. Equilateral, isosceles, scalene, acute, obtuse, right? Any one of those. All right, our first definition is going to be what's called the base. Now, the base can be any one of the 3 sides of the triangle. Now, usually, not always, but usually the bottom is the base. And it doesn't have to be the bottom. It could be any one of the 3 sides. But we simply call one of the sides of the triangle the base. The second vocabulary word describes if we were to measure the distance between the base and the opposite vertex, just not in any direction, but it's opposite. Now, we always measure distance perpendicularly, so that's why it's got that little dotted line with the square on the bottom. So the distance between the base and the opposite vertex, see where the arrow goes? We're going to call that the height. Some books would call it the altitude. This book uses height. So the perpendicular distance between the base and the opposite vertex is defined as the height. So go ahead and pause the video, make sure you have all three of those down, the definition and then the two parts of a triangle. When you're ready, go on to the next slide. All right, so we're dealing with this triangle, and we got the two parts, the base and the height. Now, it can be done in one of four different ways, and by that I mean this. Here's your standard, the base is the bottom, the height goes from the bottom to the top. But now any one of the three sides could be the base. So if the left or the right side is the base of this particular triangle, well then height won't go from the bottom to the top, it'll go from the base to the opposite vertex. Now I'm not going to draw one that comes from the left side, but it would just be the opposite of that middle one. Well, there's two other flavors that can happen. The first one is if it's a right triangle. If it's a right triangle, well, there's not going to be a dotted line because there's always one of those little white squares. See it on the bottom right? So the base is the bottom and the height is one of the sides of the triangle. Notice that is not the same as the previous two, where the height is a dotted line that comes basically from the middle of the base to the top. It's not always the middle. The last flavor is a weird one. It's a scalene obtuse triangle. And here's the issue. If we make the bottom the base, draw a perpendicular line from the base to the, well, we never get to the opposite vertex. We get to its height, but we never get to, we physically don't touch the opposite corner. So what you have to do is extend the base and move the height bar over. Extend the base and move the height bar over. Now, look, I've got a yellow triangle there. Where it says the word base is the actual base. The white part looks like we made another triangle. It isn't really a triangle. It's just showing you that the distance between the base and the vertex would be drawn as so. Hopefully that made sense. All right, so in the next box on your Google form, it's going to say identify the base and the height of the triangles. So there's three triangles there. Go ahead and pause the video and then write down the base and height of the left, the middle, and the right triangle. How'd you do? Well, let's check your work. Let's see. The one on the left, the triangle on the left, the base is 2 and the height is 3. How do I know that? Well, take a look at the little tiny white square. That indicates the perpendicular distance. That touches the base, so that's 2, and the dotted line is the height, that's 3. The 2 4s there are just simply the distance of those two sides. If we were calculating the perimeter, well, we would actually use that. But we're only doing the base and height right now. On the middle triangle, well, the little tiny square touches the base, that would be 15, and the height is the dotted line, that would be 10. Okay? 8 is not the base, even though it's the bottom, right? It's because the little tiny white square doesn't touch it. We define the base as one of the sides. The last one is that scalene obtuse one. The base is 4, and the height is 8. Hopefully that didn't confuse you. Usually the scalene one, obtuse triangle, is the one that usually causes people some problems. Okay, how'd you do? Remember from last lesson that the parallelogram has a base and a height, and the area, this is what you did your homework on last night, is base times height. Okay? Keep that in mind. What I'm going to do is we're going to calculate the area of a triangle. And you're like, Mr. C, that's not a triangle, that's a parallelogram. You are correct. Well, we know that the area of a parallelogram is base times height. If we take any parallelogram and cut it in half. See what I did there? I just cut it in half. Half the area would be there and half of the area would be there. Well, take a look what I did when I cut it in half. I made two triangles, right? So if we were to split those apart, right, the formula would still be base times height. Now, but if I erased one of those triangles, it would only be a half base times height, and that's where the formula for area of a triangle comes from. The fact that you can take any parallelogram, base times height, cut it in half, in other words, divide it by 2, and you get a triangle. So let's write that down, please. There's two formulas. They're the same formulas. The book will always say area is equal to 1/2 base times height. However, most people do base times height divided by 2. It's the same calculation. So the first one, the one on the top there, is what the book shows. The second one is kind of like more what most people do. Either one is fine. Pause the video if you need to. If not, let's move on and do some examples. So here's our first triangle. So the formula is area is equal to 1/2 base times height. We need to find the base and the height. Those are the only two variables we need to identify, the base and the height. Okay, so let's see. The little square touches the base. That would be 8. The dotted line is the height, so that would be 8 times 7. And all that's either multiplied by half or divided by 2. So I'm going to do it the way the book does it. Most people would do 8 times 7 and then divide that by 2. If we do the book way, a half of 8 is 4. 4 times 7 is 28. And remember, we're doing area, so it will be inches squared. I would recommend rewind the video, listen to that explanation one more time. If you're okay with that, move on to the next example. All right, here's another one. Let's see. It is a triangle. We're doing the area, so 1/2 base times height. Let's see. The square touches the base. That would be 10, and the dotted line is the height, so we have a 10 and an 8. Doing the book method, half of 10 is 5. 5 times 8 is 40. If you're using it the way most people do, 10 times 8 is 80, divided by 2 is 40. We get the same answer. Just remember, units are always squared because we're doing area. Okay. A little bit more challenging example this time. Notice that the height is not coming from the bottom, it's coming from the left side. So 10 is not the base, even though it's the bottom, because the square touches the base. So in this case, the base is 9 when the height is 8. So let's see. I don't want to take half of 9. Let's take half of 8. Half of 8 is 4, and 4 times 9 is 36. You could also do 9 times 8, 72. 72 divided by 2 is 36, and it's centimeters squared. All right, we're going to go through all the flavors of these triangles. So here's one of the ones where it's a right triangle. Notice no dotted line, but the square touches the base and the height. So the base and the height for this one are 10 and 7. Hey, there's the bell. Ignore that. All right, and yes, I am at school. Let's see, 1/2 base times height. So 1/2, 10 times 7. Half of 10 is 5. 5 times 7 is 35. So 35 square inches. Okay, or 10 times 7 is 70. Half of 70 is 35. Got it? Okay, so here's what I need you to do. 3 examples to calculate the area of a triangle. Go ahead to the next, or pause the video, go to the next box on the Google Forms. Give me the area of all 3 of these triangles. Area of all 3 of these triangles. Once you have calculated all 3, play the video and let's check our answers. How'd you do? All right, let's check our answers. Let's see. Christian, first one, what you get? Wait, what? No, 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 no. So let's see. Let's find the square. The square is attached to the base. That's 2. The height is 3. So 2 times 3 is 6. Half of 6 is 3. So 3 square inches. All right, you got that one now? All right, who wants the next one? Who wants the next one? No, Shepard, no. You always get all the questions. Let's choose Amanda. Amanda, what you get? Yeah, that's right. That is right. That's 75 square centimeters. Notice the square touches the base, 15. The dotted line is the height, 10. 15 times 10 is 150. Half of 150 is 75 square centimeters. Good job. All right, hardest one, the last one. Meryl, what you get? Yeah, good job. Good job. 16 square meters. So the scaling obtuse one usually fools people. It didn't fool Meryl. Let's see. The base is 4. That dotted line, the white part is not part of the yellow triangle. So the base is 4. The height is 8. 8 times 4 is 32. Half of 32 is 16 meters squared. For those of you that need it, rewind the video. Watch these examples one more time. Finding that little square is key to finding the area of a triangle. Okay? For the rest of us, new stuff. All right, next shape. Write this down in your notes. From quadrilaterals, remember this is one of our quadrilaterals. This is the trapezoid. Trapezoids are unique because 4 sides and 2 of the sides are parallel. Notice A, B, and DC are parallel. That's the symbol for parallel. All right. Take a piece of paper. Go ahead and draw me a quick trapezoid. Draw me a quick trapezoid. All right, we're going to label the parts. For trapezoids, the 2 parallel sides will be called the bases. Now, one of them is going to be called base 1, base 2, because notice they're not the same size. But the 2 parallel sides will be called the bases. And it doesn't matter which one's base 1, base 2. If you always want to make the bottom one base 1, that's fine. Okay, the distance between the 2 bases will be determined as, or we will call that the height. So the perpendicular distance between the 2 bases is called the height. So there are your two parts of trapezoids. If you need to pause the video, do that, but make sure you copy this down in your notes. Okay, so the first thing we're going to do is just simply look at the different flavors of trapezoids and see what the base and the heights look like. All right, notice the one on the left. That's your standard one, or the top and bottom are your two parallel sides. One's called base 1, base 2, and the distance between the two are called the height. That's the typical one that you'll see. The middle one is where the two parallel sides are left and right, but still, it's the same thing. The two parallel sides are the bases, and the distance between the two is called the height. The last one is kind of the more unique one. This is called a right trapezoid, and since one of the angles is right, then that side becomes the height now because it touches the little tiny square. But still, the two bases are the parallel sides. If you need to pause the video and look at this carefully or write down these examples, please do that at this time. Okay, usually I show you where the formula comes from first and then ask you to write it down. This time, I'm going to show you the formula. Please write it down. For any trapezoid, the area is equal to 1/2 height times the quantity base 1 plus base 2. Now PEMDAS or GEMDAS would make us do add the two bases first. That B1 means base 1, the B2 means base 2. Okay? Well, that's kind of weird, so where does this form, or pause if you need to write the formula down. So where does this formula come from? Let me explain it to you. All right. So let's start with a trapezoid. Right? The two parallel sides are called base 1 and base 2. And let's measure the distance between the two bases. We'll call that the height. Okay? So we got base 1, base 2, and we got the height. Okay. I'm gonna cut this trapezoid. Now I can't say that I'm cutting it in half because we don't know the distances, but it sure looks like we're cutting it in half. But notice when I cut it from one corner to the next corner, notice I've formed two triangles, a yellow one and a blue one. So if I wanted to calculate the entire area of the trapezoid, it would be the area of the yellow one plus the area of the blue one. Make sense? Okay. So now let's look at the yellow one. Well, the yellow one would have the base of base 1. It would have the height of height. Okay, so that would be base 1 times the height divided by 2. Remember, that's a formula for area of a triangle. And for the blue one, well, we need to find the height. Where would the height be? Well, the height, because this one is one of those scaling obtuse ones, we would do the height off to the side. But notice, those two heights are exactly the same measurement. What's different are the bases for the blue one. The base is not base 1 for the blue one, it's base 2. So the second one would be base 2 times height divided by 2. So there is kind of the formula. What they do is they simply do a little bit of algebra. Notice both of them being multiplied by height. So they combine the two. They got the same common denominator, 2, and then they pull out the height. Okay, so that's why they get base 1 plus base 2. Don't get too hung up on that algebra right there. Just realize this is where the formula comes from. Okay, so we have our formula. All right, let's do an example. I'll just pause right here. Many students use the second formula there, the base 1 plus base 2 times the height, then divide by 2, rather than the previous one. Either one is fine. Okay. Area of a trapezoid. Let's do an example. So there's our formula. We got to find the two bases. Well, the two bases, the square touches one of the base, and the arrow points to the second one. So the two bases are 6 and 4, and the height here is 6. Okay, so if we plug those numbers in, and then follow GEMDAS, we got to do parentheses first. 6 plus 4 is 10. Okay, half of 10 is 5. 5 times 6 is 30. With a calculator, 10 times 6 is 60. 60 divided by 2 is still 30. Makes sense? If you need to pause the video, replay this example, please do. If not, let's do another example. So here's another example. All right, so let's see. We need the two bases. The square touches the first base. The arrow points to the second base. So the two bases are 10 and 8, and the height is 6. 10 plus 8 is 18. Okay, do the parentheses first. Half of 18 is 9. 9 times 6 is 54. With a calculator, 18 times 6 divided by 2 still gets you to 54. Got it? All right, let's do one together. All right, on your piece of paper, let's see. We need the formula. We need to find the two bases. Well, the square touches one of the base, 6. The arrow points to the second one, 4. So my two bases are 6 and 4. and the height is 5. All right, let's see. 6 plus 4 is 10, using GEMDAS. Half of 10 is 5. 5 times 5 is 25. Or 10 times 5 is 50. Half of 50 is 25. The units are inches, so inches squared. Make sense? All right, if you need to rewind, watch those 3 examples, please do that. If not, there's 3 that I'd like you to do all by yourself. Answer the last question. The last question simply says, what is the area of the 3 trapezoids? So go ahead and do that, pause the video, and then play the video, and let's check our answers. How'd you do? All right, let's take a look at the left one. Well, let's see. The bases are 4 and 8, and the height is 6. 4 plus 8 is 12. Half of 12 is 6. 6 times 6 is 36. So 36 square centimeters. The middle one, let's see, the bases are 7 and 2. The square touches the base. The arrow points to the second one. So 7 and 2. The height is 5. 7 plus 2 is 9. 9 times 5 is 45. Half of 45 is 22.5 inches squared, or square inches. The last one is that weird one, the right trapezoid. The square touches one of the base, and that side is the height. The bases are 7, 10, and the height is 6. Okay. 10 plus 7 is 17. Half of 6 is 3. 3 times 17 is 51 square centimeters. All right, how'd you do? Oh, you got all 3 right. Good job. Trapezoids are a little bit troubling at times. In fact, the hardest thing is to remember the formula. Luckily for you, either on the state test or any test I give you, you got to bring a formula sheet, and it always has the area of a trapezoid. It's one of the harder ones to remember. All right, so we did the area of both the triangle and the trapezoid. Rewatch the video if you need to. If not, there's your homework. Go ahead and get started on that, and I will see you guys tomorrow.